Okay, today's class is on the CO. Okay, CO is what the computer organization. Okay, this is the motherboard of our CPU. Okay, that's the thing. Set up processor, whatever we have. This is the CPU. This is the processor.
Yes.
This is the what the processor. This is processor. What type of processor is it? Microprocessor. Microprocessor. So many processors are there. Just among them, this is one of the microprocessor. This might be Intel i3, i5, something whatever, and Intel something are there. So many different types are there. But leave it. Okay, let them do that. Come. How are you? Very good. Okay, this is what the microprocessor we have. Okay, this microprocessor we can be using the other motherboard. This is the slot for the RAM. This is the slot for the RAM, and this is this SIO serial input output. Okay, this is also okay. So many ports are there. Okay, and also this are some Ethernet connections and all. Okay, we have. But you should have to remember where is the memory, where is exactly our processor is there. External memory is there. External memory cards are there. These are the memory cards. Okay, RAM cards. Actually, RAM. External memory is there. Okay, these are the RAMs. And also, okay, RAM are there. I have it. I will show it. Okay, this is the processor. Okay, where we are using. Okay, we can insert any type even. Thank you. Okay, this one is the RAM. Is it right? Okay. Okay, this is there. Okay, and this is our external hard disk. This is the memory. Okay, this is what the memory, actual memory. Okay, this is the hard disk. Means what we have the external memory where we have the our programs are stored usually where in the RAM or ROM. This is the ROM, external memory. Whatever writing the programs, those programs will be stored there in the ROM. That's the external hard disk. This is the hard disk we will be using each and every processor. This is the whatever I am showing. These are the hard disks which are related to our desktops. Okay, desktop computers. Okay, these are the desktop computers. This is the motherboard, and also we have CD hard disk. Okay, this is the CD and that's the DVD one. Okay. Something you should have to know. Our main CO subject is only focused on these objects only. Okay. Okay.
Zaid, sir.
Stop writing. Okay, writing there. Okay, CO subject is completely depends on this. This is the main. Okay, this is the backbone of our CO subject. What is that? So that this CO subject completely will be studying the about the processor. Okay, processor, how the processor is interconnected to our I/O devices and also memory devices. Many things we have. Okay, first chapter is the only the mainly the CPU. That's the architecture of our processor. Something he has not clearly decided now. He has not shown our complete architecture in your syllabus. Whatever you want to go to the real architecture of it. That was somewhat very free-handed that now. But today we will see the what the exactly architecture you need. Okay, here the each and every registers, program counter, and also some other general purpose registers, temporal registers, and also auxiliary other registers, and also even we have the flag registers, and also instruction register. These are the registers. Okay, and also we have the instruction decoder is also there, and also control unit is there, and also interrupt control is there, and also we have the serial input output connections and all. Okay, these are all whatever I will be showing here. But this is the exactly what you need to study in the CO subject. But in your syllabus, the book he has not clearly shown. Okay, today I will draw some architecture of the 8085 microprocessor, which is not in your exact syllabus for your syllabus. But anyway, I will try to show what the contents of what the parts of our 8085 microprocessor. Okay, CO is completely based on this microprocessor only. The 8085 microprocessor is one of the basic microprocessor. This is the basic microprocessor. We'll be using that the base to our backbone to our CO subject. You should remember. Okay, you have to should remember 8085 microprocessor is one of the basic microprocessor, which is the backbone of our CO subject. Okay, whatever I will be explaining the teaching today, the parts of the microprocessor, those to be used whenever I will be using each and every class. Okay, for coming classes in the CO subject, I will be using many times. I will be calling the some register names and also flag names and all. Those to be what they are not shown exactly in your syllabus or in your book. But today I am drawing that I got the some other content from the internet and other books. The exact diagram of architecture of the microprocessor I will be showing in the given. I will be introducing the some about the each and every parts of our microprocessor. Okay, that will be basic, and even you can also say that backbone of our CO subject. Okay, let me draw the figure first, then next we will see. Okay, this is the exact whatever this figure I am drawing here. This is the exact figure. What thing is that I am showing the lines of lines and also data process exactly. Okay, how I'm drawing them. Okay, you can also draw as it is. No, it's important for not necessary to you just if you want to understand what the CO subject, then you should have to remember this figure exactly what I am teaching here. But in this is the architecture not in your syllabus, but for the understanding of the CO subject you should remember this figure. Whatever. Okay, just I am trying the 8085 microprocessor here. I have registers. Okay, whenever I call the registers, that's the microprocessor consists of the many registers are there. The other we can say this is what we call the array of registers. This is what we call the array of registers. This can be divided into two parts as the WZ. Okay, WZ, and also we have the B, C. Okay, and also D, E, and also H, L. Okay, H and L. H, L. Okay, these are the stack pointer. Stack pointer. Stack pointer. This is the program pointer. Okay, this is the implementer and decrementer. Implementer and decrementer. I have two addresses here. I don't know as it is. Copy this one. Right? Fast. Do it fast. Okay, right fast. Copy this one exactly. very fast study. Okay. All of you remember one thing? Okay. Shh. They will be there. They will be there. So there is no stop it. Just pass the class. Others will continue. Okay, this is what the this is the architecture of the 8085 microprocessor. This is the main architecture of the microprocessor. This is one of the basic microprocessor we are using here. Okay, this is the main architecture we need to study here. But the thing is that for your syllabus we don't have this complete architecture. We have a different. Okay, that's somewhat a very simple one. This is the complex. Okay, this is the exact whatever the exact we need for the for our syllabus. We need what are the component, what are the these are the parts we need to study in our CO subject. Those are all mentioned here. Okay, this is the main architecture of the microprocessor. Okay, one more thing. This is the completely backbone of our CO subject. If you know the complete, these are the simple parts. If you know this one complete architecture, how the data flow will be happening, how the instruction will be fetched from the memory to the program processor. This is one of the basic things we need to study. If you know the complete architecture, how the data is flowing, how the instruction is fetched, executed, then definitely you can easily write the for you can also study the CO subject here. Okay, this is the main hardware component I shown here earlier. Okay, this is once again I am showing here. This is the processor. This is the RAM. Okay, RAM. Okay, and also we have the cache memory. Cache memory is already stored in the completely in the processor itself. We don't have a separate cache here. Separate cache here. You should remember. Cache memory is always in the processor itself. This is the main processor here. We need to study here, and also some Ethernet and all connections also. This is the RAM. Okay, this is the RAM. RAM component is there. We can insert the RAM components here, and also we have the main. This one is to be we can study here. Should we make one? Okay. This is the main hardware component of the this is the processor. Okay, this is the main processor we will be studying here. In this processor we have the cache memory. You should remember. Separate we don't have the cache memory. Cache memory component is not there. There is no separate component for the cache memory. You should remember. Okay, this is the main program. This is what the processor will be having here, and also I am inserting this one exactly. Okay, this is the mechanical mode. Okay, this is the RAM. Okay, this is what the motherboard of our computer. Okay, and also this is the RAMs and all you can insert here. This is the hard disk. Okay, this is what the external memory. This is what the external memory will be using. For every time we will be writing the programs and all, where the programs are stored in the memory, the hard disk only. That's the external hard disk. Okay, there is no separate RAM. So there is no separate memory, built-in memory for the processor here. So cache itself is some small component, some small amount of memory is there. But thing is that there is no separate, there is no built-in memory for the processor here. We have the external, we will be having the memory. Always you should remember. Okay, this is the main hardware component we use in our CO subject. You should remember. Okay. Whatever I have shown you about, okay, this is what the architecture. This is what the architecture of what the architecture of the 8085 microprocessor. So many microprocessors are there. So many microprocessors, 8085, 8086, then Penta, something very, so many are there. Okay, and also you have the i3 processor is there, i5 is there, i7 is there. So many coming are there. But this is one of the 8085 microprocessor is one of the basic microprocessor. This is for the 8-bit microprocessor. We have the 8-bit microprocessor. It means each and every hardware, each and every register will have the capacity of storing only the 8-bit capacity. That's what we call this for the 8-bit memory, 8-bit microprocessor. This is for the basic microprocessor. We have the 8-bit integral bus will be used every time, 8-bit integral bus, but not type of microprocessor using the 16 something or whatever. But this is why we call it the always 8085 microprocessor. This is earlier it was the 80, actually 8080, and its name was given also one more time 8084. That earlier one more version came the 8085, the perfect microprocessor. This is the main microprocessor will be using. Okay, this is the main microprocessor. Okay, this is the my architecture of 8085 microprocessor. Okay, there are so many blocks are there. So okay, first you come to the this is what the array of registers. This is what we call the array of registers. So many registers are there. W, Z, B, C, D, E, H, L. So many registers. This is what the stack pointer. This is the program parameter. This is what the incremental and decremental. Incremental, decremental also there. Okay, incremental, decremental is also there. Okay, and also we have the instruction register is there, and also accumulator. There are should be numbers. Accumulator, instruction register. I will explain each other. Okay. Flag register. Flag register. Okay. This is for the main. Okay. First you remember here the number of registers. This is called the array of registers. Okay, there are 7 registers. So there are 7 general purpose registers. You should remember. What are those? B, C, D, E, H, L, and also accumulator. Accumulator is also one of the general registers. Okay, if you don't mention anywhere in the while writing the instruction, but we built in the accumulator as built registers, and also we can also use the B, C, D, E, H, L. These are the 7 registers available for the programmer to write the program. You should remember. W and Z are the temporal registers. Okay. W and Z are what called the temporal registers. These are used by whom? Only the processor. Only the processor. While calculating while doing the operations, it will be using the W and Z are called the temporary registers. Temporary registers. You should remember. These 2 registers are not available to what the programmer will not touch. Okay. These are what the imaginary. These are what called the imaginary registers. Okay. These are the abstract. We cannot see these registers. But these 2 registers are used by the processor. These 2 registers are used by the processor. Okay. These 2 registers are used by the processor. Okay. Complete registers box is there. We can say it's for the mux. Mux is for the multiplexer. Mux is for the multiplexer. We can set any one registers while writing the program, while writing the instruction code. Okay. How many registers are there in the general purpose register? There are 7 general purpose registers are there. One is B, C, D, E, H, L. Each and every registers have the capacity of how much? 8-bit of storing capacity. 8-bit capacity. That's what we call the 8-bit registers. 8085 microprocessor for the 8085 microprocessor, 8-bit microprocessor. You should know. Stack pointer is the one we can say. It will show it works always to with the push and pop instruction. There are push and pop operations. It will store the data, whatever the data we need here. And also, always you should remember, program is always to do from the incremental operations. Only the incremental operations. Push operations will always put the incremental. Pop operation will always turn to the decremental. Okay, whenever. Okay, I'll explain each and everything. And also incremental, decremental is also working together while doing push. Just to remember. Okay. And also one of the 2 buffers are there. 2 buffer registers are there. One is what the address buffer is there. Another is the data or address buffer is there. Data address buffer. Just to remember. Okay. And also here the arithmetical logical unit is there. This is what the arithmetical logical unit. It will perform the arithmetical logical operation. Just to remember. This is the timing and control unit. This is the main box. This is the main control unit. This will only controls complete our architecture. Complete processor. Who will complete the timing and control unit. This is the control unit only. It will control all complete processor, all the parts of our processor. And also this is the interrupt control is there. Okay, there are some other interrupt controls complete our completion of our instruction execution, and also program. Then we get the output will be displayed toward the serial input output control unit. Okay, these are some units. Okay, first you remember there are 7 general input resistors, and also control unit is there, and also arithmetic logical unit is there, accumulator is there, interrupt control unit is there, serial input output control is there. You should remember there are 5 parts of it. Okay, first. Okay, if you want, when your programmer usually write the programs, therefore for the instruction. Yes or no? Programmers will be writing the programs in the form of what? Therefore the number of instructions. Coding is equal to the number of instructions. If they write the sum of instructions, okay, some instruction. This is the program. This is the program. What is the program? The number of instructions are used to write the program in order to perform the particular task is called the program. In our CO subject, but in our other subjects I don't know what is the function, what is the definition. You should remember. Okay, whenever you write as a developer, as a software developer, you will be writing the program here in the as a directly in the processor. No, you will be writing the in the hard disk. External hard disk. This is called the external memory. Okay, this program has to be executed one by one. First instruction has to execute. Second instruction has to execute. Serial it will be executing one by one. Then only complete programs will be executed. For this purpose, I need to fetch this instruction. The instruction which is going to be executed, it will need the it will work under what the 3 stages are there. One becomes the fetch, another one is called the decode, another one is the execution. Okay. Okay, execute. If any one instruction is there, one instruction is to fetch. First it has to fetch the instruction, then it has to decode, and next is for the execute that particular instruction. Similarly, it has to be complete program has to be executed, means each and every instruction has to go through it with these 3 operations. First fetch, decode, execute. Fetch, decode, execute. Okay, let me take one example. Okay, I am writing the some program is there. Okay, let's show what the some other program is there. I am writing the one program in this instruction. I will take one instruction add add B is there. Okay, just to remember add B. Okay, add B is one of the instructions in our program. This program this instruction has to be processed in my microprocessor. How? Okay, then first we will control that one. Not the first controller, process signal. While ambient controller, it will send some signal. How? It will be sending some signal here. Just is going through water. Okay, this is going through water. Control signal here. Control signal here. Okay. This is control signal comes to where to the water. This is the data bus here. Okay, this control signal will send controls to the data bus. Okay, from the data bus only it will fetch the instruction. First instruction. Okay, first the fetch one. Who will send the control signal? First timing controller. Is the boss. From timing controller is the boss. Okay, it will say that fetch that particular instruction. Execution of program started. First instruction will execute. Fetch. Okay, this instruction has to be executed. It has to go through what the 3 stages are. One is what the fetch. Second one is what the decode. Third one is the execute. First it will fetch the instruction add B. Okay, where it will come exactly? Add B comes where in the data address. What the data is here? Okay, what the data is here? Data and address bus is what the 16-bit only. 16-bit only. It will build on say bus only. It will build on address and data bus. But the data is what the DA to D15 is separate. DA to D15. But address is what the only 8 bits is the. But this data is the 16 bits. Address is the only 8 bits is the because of the 8-bit internal bus is there. Address is always with the 8 bits only. Data is it will be around the 16 bit. 16. Just to remember what I am saying here. Okay, this is exactly it will come where in the here. But it comes exactly where in the program counter. Okay, program counter is going to be holding the particular instruction which is going to be executed next. It should hold the particular instruction which should be going to be executed the first next. That will be held by whom? Program counter. Program counter is incremental or decremental down. Increment of the decrement ಆಗುತ್ತೆ ಇವಾಗ increment ಆಗುತ್ತೆ because it comes okay. It means what the it will be increment now. It will be incrementing now. Now the program code is what the increment ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ it is taking one instruction. It is taking what the one instruction comes where in the program code. Program code will be incrementing now. Now it is identifying. Okay, it will send it where in the to the what the instruction register. To the what the instruction register. To what the instruction register. Instruction register is one of the components. This is the one of the register which will hold the instruction which is going to be executed. Currently which will be executed. Program code will be holding the what the address of that particular instruction which is going to be fetched earlier. Okay. Now you have next instruction execute next instruction. That will be stored in the program counter. Instruction register will end with the that will holds for the only the instruction which will be going to be executed now. Now whatever the fetching first and instruction is fetching there. That will becomes where the that will comes where the that will coming where coming it's coming to our instruction register. Instruction register is the one of the register which will be holding the only the particular instruction which is going to be executed now. Okay, next instruction register that will be decoded. That will be what the machine coded. Again, the machine code that will be converted to what the English language is. The ADB, what are the add something that will become converted to what the machine language something 10 something by the coding. That will be done with what the instruction decoder. Fetch is over here. Fetch is over. Decoding is happening. Next is what the execution. Execution process will be done by whom? This is the control unit. Control unit will decide what type of execution, whether it is a arithmetic operations or logical operations. Arithmetical operations is addition, subtraction, something it will do. Logical operations is AND, OR, XOR operations it will do. But who will decide that one? But by the control unit, it will decide what the type of instruction is, what the operation it has to perform. That will be sending the signal. Here. What the sending the signals here? That will be sending the signals here. Okay, that will be sending the signal. Signals always control bus is there. This is what the data bus. This is what the data bus is there. Two-sided face is what we call the database. Single-sided face we call the address bus. Single lines are called the control signals. Control bus control signals. ಯಾವುದೇ single line ಕೊಟ್ಟಿರಲ್ಲ ಅದಕ್ಕೆ ಏನಂದ್ರೆ control signals. Okay. This is the control signal sends this information to where in the arithmetical logical unit. You have to perform the particular operation here. Addition operation you have to do. Logical operation to performing here. Some after the performing the operation, while performing the operation, it will take the two values here. Any operation, if you want to do particular operation, we need how many values? Two values. Here, how many values I am sending here? Only one value. That's what the contents of what the B registers. Contents of the B registers. Okay. That another value I need here for performing. That is nothing but the accumulator. Default. If you not mention any register here, one more register here, it will take the accumulated data from where the accumulator register. Accumulator register is what the one of the default register. It will take, if you not mention any one more two registers for that, it will take another register from the simple accumulator register. Okay, accumulator register. Okay, from the I not mentioned here. Okay, this will do one of the arithmetic operation it will perform because of the add operation. Add signal is there. Add instruction is there. Then it will take the values. Okay, data from the B register. Another data from the accumulator register. It will perform what the addition arithmetic operation. Here while performing the addition operation, arithmetic operations, what are the operations? We are getting the some results. We are getting what type of result this is? Is it 0 result? 5 plus 5 is how much? 10. Okay, E1 we are getting E1 parity. 5 minus 5 subtraction is 0. 0 flag will be raising. If it's the correct result, okay, that one. Okay, if there are 5 flags are there. Flags are nothing but some registers. Okay, this is also called the 8-bit registers. This is also 8-bit registers, but we will be using the only 5 flags. 3 bits are not at all used in the microprocessor. Not at all used in the microprocessor. It means here the any register is there. If 8 bits means for the this is for the registers. You should remember. 1, 2, 3, 4, 5, 6, 7, 8. The register. Okay. These 4 bits are used in the flags. Okay. What are the flags here? I have to use here. Some flags are there. Okay. Flags are there for the yes is there. Sign flag is there. 0 flag is there. Auxiliary carry flag is there. And also we have a parity flag is there. And also okay same flag is there. This is the sign means what the when you are getting the negative answer. Sign flag result. Result 0 5 minus 5 result is 0 is the 0 flag result. Allade auxiliary carry flag. Auxiliary carry the 4th bit alli carry ಬಂದ್ರೆ ಅದು auxiliary carry ಆಗಿದೆ. Okay, next is what the parity flag. Parity means what the parity is. Even parity or odd parity. Result is even or odd ಅಂತ ತೋರಿಸ್ತದೆ. Okay, next is what the carry generate ಆಗ್ತದೆ. After the addition of the 8 bits, 9 bit carry generate ಆಗ್ತದೆ. We have seen in the parallel addition. Okay, as you already seen now. ಅಲ್ಲಿ carry generate ಆಗ್ತದೆ. ಎಷ್ಟು carry generate ಆಗಿದ್ರೆ single flag. This means what the these particular 5 flags will be raised. 0 result 0 is ಯಾವ flag raised ಅಂತ 0 straight flag raised ಆಗುತ್ತೆ. Negative ಅಂದ್ರೆ side flag raised ಆಗುತ್ತೆ. Carry from the 4th bit to 5th bit ಇದ್ರೆ auxiliary carry flag generate ಆಗುತ್ತೆ. We will be raising. Okay, this is what the answer we are getting. That will be stored there. Okay, next instruction register is one of the this is what the temporary resistance. Okay, before while resulting, if you are getting the result there, will be storing the temporary resistance. If you are using the reuser, okay, if you are using the particular result once again, then you can store using the temporary resistance. Okay, next you come to the complete. Okay, this is all about the our controls. Okay, these are some resets are there, some control units are there. Status will be studying each and every in the 3rd and 4th model and also 5th model. This is the one of the basic architecture you should have to remember. Okay. Okay, we will do the seminar now. Okay. I hope you all follow this. This is the main method. Whenever I use the incremental, instruction registers, okay, status register, these are status flags. You should remember all these things. Okay, this is the main. Okay, this is not they will not ask for in the examination. Don't completely study and practice it. Okay, this is not your syllabus. I have some other architecture there. That's the simple. This is for your reference purpose, for study purpose only. Okay, for the study purpose only. Don't take this much. So it's very seriously and just remember where the components are there. Okay, in the architecture of the 80 microprocessor, 85 microprocessor. Okay, this is all about first time now. I need to cover something. This is what the architecture is now. This is not very simple. If you understand this one, it will be easy for you. Okay, so let us do this because we are the similar topic.